So this is for activity 5, unit EM for S1 and S2. And it's basically just asking for different diagrams showing different states. So for S1 part A, it's asking for a diagram of the system of interacting objects in the transient state, where the battery and the motor fan are still increasing in temperature but are already warmer than the surroundings, and the fan is increasing in speed but it's already pushing air away from it. So for the first diagram, it's this middle one. I know there's scribbles everywhere, I'm so sorry. So the battery is increasing in thermal energy, and I forgot to mention that it's decreasing in chemical potential energy, because obviously the battery is handing over its energy to the motor fan and its surroundings. This arrow is going the wrong way. But the motor fan's surroundings are increasing in thermal energy because the fan is starting to get hot, and the surroundings of the battery are increasing in thermal energy because the battery is heating up as well. But the air off of the motor fan is decreasing in thermal energy because as it's picking up speed, it's going to blow cooler air away, because the faster it goes, the cooler it's going to feel. And for part B, it's asking for the statement of conservation of energy of this system. So there's the decrease of the chemical potential of the battery is equal to the increase of kinetic energy of the air, plus the increase of thermal energy of the fan, plus the increase of the thermal energy of the surroundings in total. And that's the only way I can really think of how it's gonna go, because there's really no other decrease in the system. I mean, besides the thermal energy of the air, but I'm not sure if that counts yet, just because it's just picking up speed and it's not exactly at the speed that it's going to be going. And for S2, it's asking for when the items are in the equilibrium states, which basically means that they're at a constant temperature and a constant speed. And that is where this diagram comes into play. So the S2 diagram has the dry cell battery. Hold on, my little pointer. The dry cell battery, it's decreasing in chemical potential energy because it's still giving its energy no matter what. And it's increasing in thermal energy because it's still providing energy to the fan and its surroundings. The surroundings are still increasing in thermal energy because it's working off the steam from the battery. The fan surroundings are also increasing in thermal energy because the fan is still running, and the air is increasing in kinetic energy, forcing it to go faster. And if it's already at a constant speed, then that means that the air is decreasing in thermal energy because the fan is already spinning fast enough for it to be in a cooler state. And that is all for activity 5.